Hello and welcome to the Autodidact Scientist Algorithm series, where I will be giving you an intuitive insight into a variety of algorithms that are used in machine learning. I'm your host, Rich Gregson, and before we get started, I would greatly appreciate it if you would like this video and subscribe to the channel. So, what algorithm are we going to cover today? And we are covering the random forest. Now, random forests are supervised machine learning methods that are built from decision tree algorithms. The random forest algorithm is used in a variety of different industries, including banking and e-commerce and the pharmaceutical industry as well. And they're generally used to forecast behaviors and to forecast outcomes. Before we dive in, let's clarify some key terms which are going to really help you to understand random forests. The first one is a root node. Now, the root node represents the entire population or data set, and this from the root node gets further divided into two or more homogeneous sets. Splitting is the process of dividing a node into two or more subnodes, and a decision node is when a subnode splits into further subnodes. That's where the splitting takes place. Now, a leaf or terminal node are the nodes that are unable to split any further. It's a node with no other children. Pruning is when we reduce the size of the random forest or decision tree, and we do that by removing nodes. And a parent and child node, that refers to a node which is divided into subnodes. The higher level is called the parents and the lower level are the children. Also, what I think will be helpful is having a quick recap on what a decision tree is. The foundation of the random forest algorithm are the decision trees. And a decision tree is a decision support method that has a structure like a tree. And I'm only going to run through it quite quickly, as I've already done a video on decision trees, which you can find here. So there are three elements that make up a decision tree: a root node, a decision node, and the leaf nodes. And a training data set is split into branches via the decision tree method, and those branches are then further subdivided into other branches. And this pattern repeats itself until a leaf node is reached, and a leaf node cannot be further split. They contain the outputs of the algorithm. And the decision trees nodes correspond to characteristics that are used to forecast the result. And the leaves are connected by the decision nodes. The three category of decision tree nodes are depicted in the diagram. And as you can see, it starts with the full sample at the top, and it works its way down until the leaf nodes are selected with the potential outcomes. Okay, so we've gone over a couple of key terms, and we've also gone over a very brief recap of decision trees. So what is a random forest? A random forest algorithm, it's used for tackling classification and regression problems, and it makes use of something called ensemble learning. And that is a method for solving issues by combining a number of algorithms all together. In a random forest algorithm, it's composed of many different decision trees. So that indicates, the forest in random forest. And these decision trees, once they're all sort of strung together, they're trained by something called bootstrap aggregation, which is also known as bagging. And what bagging is, or bootstrap aggregation, it's an ensemble approach that combines the predictions of all the individual decision trees contained within the random forest model. And what it does is fit them to various subsets of training data. Now, in the case of the random forest, the random part is that the algorithm randomly chooses portions of the data set to feed into the forest of decision trees. So because of this, bootstrapping produces numerous smaller random data sets that are selected from the original parent's distribution. And every bootstrap data set is then used to train the model, and the results are aggregated to produce a single outcome. Now, The term aggregation potentially signifies different things depending on the kind of issue that you're trying to solve. Aggregation in the context of a regression problem refers to averaging each observation outcome across all decision trees, while in the classification, the aggregation refers to choosing the class that gets the majority vote. And because all these individual outcomes are bootstrapped and aggregated, each model is trained, each individual decision tree is trained on a distinct data set. And as a result, it's pretty much inevitable that each model will have a unique error and have a unique variance. In the aggregation step, where them results are essentially averaged out, in the case of regression, for example, both the error and the variance are minimized. So what does the random forest methodology look like in terms of what we've just discussed? So the first step is that we start with the original data set. We generate n bag samples of size n, and where n is the number of samples that are going to be created. And then within each of these n bag data sets as input, we need to train a decision tree. We don't, however, look at every feature in the data set while we do a node split. What happens is that it chooses m features at random from the entire training set of features, and then using impurity metrics like Gini impurity or entropy, it chooses the optimal split. The next step, step 3, is combine the outcomes of each decision tree into a single output. Step 4, if you're working on a regression problem, we average the results for each observation as produced by each tree. And step 5, if we're working on a classification task, we do a majority vote across all trees for each observation. So as you can see, the random forest is quite powerful. It's not necessarily complicated, as it's just a large group of decision trees all put to work on small samples of the original data set. So what are the advantages and disadvantages of a random forest? The advantages are that it reduces overfitting in decision trees and helps improve accuracy. It's flexible, both for classification and regression. It works well with both categorical and continuous values. It automates missing values when they're present in our original data set, and normalizing of the data isn't required as it uses a rule-based approach. However, there's no free lunch. There are disadvantages, and some of them disadvantages are that it requires much computational power as well as resources as it builds numerous trees. So, because it's using a number of algorithms simultaneously, it does eat up your computational power. And because of that, it also requires a lot of time for training. And because of the ensemble of decision trees, it also suffers quite significant interpretation issues, and it's much more difficult to determine the significance of each variable in relation to the output. Despite the disadvantages, the random forests are used in many different circumstances. It can be used in pharmaceutical industry to determine a medicine's potential, or perhaps the makeup of ingredients needed to create the particular medicine. It can also be used in hospitals to determine a patient's likelihood of developing cancer, as well as many other diseases. And it can also help in early diagnosis, depending on a number of features or information about the particular patient. In the financial world, I've seen them be used for fraud detection, stock market prediction and analysis. And in sort of e-commerce, e-commerce circles. They can be used for customer segmentation, product recommendation, search ranking, and price optimization, for example. And that concludes our brief look at random forests. Now, I hope this video has helped you get an idea of how random forests work, how they differ from decision trees, and what we can use random forests for. If you have any questions, comments, or feedback, please contact me personally through my social media channels or through the Autodidact Sciences channel as well. Remember, please like and subscribe, and I'll see you next time. Thanks very much.